All right, so let's go ahead and start talking about quantum numbers. Now, quantum numbers essentially tell you the location of the electron within the electron cloud. And so there's four quantum numbers that tell you where that location is. And so let's go ahead and go through these four numbers. We have N, we have L, we have M, and we have the spin. And so the first one is really easy. It tells you the energy level, which if you take a look, this n equals 2 here, n equals 3, n equals 4, n equals 5, and so on. And so if something is in this row right here, it's in the second energy level. Now something I do want to point out is notice how for the D blocks, even though this is the fourth energy level, notice how the D block goes down by 1. And so if something is, let's say right here, even though it's in the fourth row, it's going to have an n of 3. Now the second number is really easy. The second number tells you which block it's in. And so S's are 0. The P is missing here, so P is equal to 1. D is 2, and F is 3. And so if something is, right there, it's in the P block, so its second number will be a 1. Now the third number, that one is probably the more confusing one, but it's really not that bad. And so what it does is it tells you what position in the orbital it is. And so if we were to think about the p orbitals here, and we were to think about these three positions, this third number tells you the position in which it's in. And what we do is we call this -1, 0, 1. D block would be -2, -1, 0, 1, 2. And so notice the symmetry there. S would just be 0. And so if we have an electron that's in this position, its third number will be 1. If it's in this position, it'll be -1. But there's actually a way to look at the periodic table to determine this. And so let's go ahead and take a look at the periodic table to see how we can determine this third number. Notice how, let's take the P block for example. Notice how all of these are -1, and then 0, and then 1. -1, 0, 1. And so by looking at the periodic table, you can actually determine which one is which. And so for example, if we have this here, if this is 2p, this would represent this. So this would be -1, 0, 1. And then we would add here, so okay, that would be this one. And then if we add another one here, it would be this. So notice how it goes, -1, 0, 1. But then what do? We pair them up, and it goes -1, 0, 1. And so it does that for everything in the p orbital. It also does that for the d orbital, the f orbital, and the s orbital even. And so let's go ahead and see how we can determine what that number is. So it goes -1, 0, 1, -1, 0, 1. Now notice how the d orbitals is the same thing, except for the d orbitals start with -2, -1, 0, 1, 2, -2, -1, 0, 1, 2. And so notice how this here, you can see that it starts with -2, it counts 2, 2, and then it repeats itself. And then F block is the same thing, except for it starts with -3. So it goes -3, -2, -1, 0, 1, 2, 3. And then it repeats itself, -3, -2, -1, 0, 1, 2, 3. And so that's the third one. And then just a side note, because S's only have one orbitals, they'll always be 0. So they'll always be 0. So S's will always have a value of 0. Now, the last one is the spin, and so let's think about the P block. So how do we fill this? Well, we go up spin, up spin, up spin. So the first three arrows we put are all up spins, and then we go down spin, down spin, down spin. Now, if an electron is an up spin, it's going to have a, if it's an up spin, it's going to have a positive 1/2. If it is a downspin, it's going to have a negative 1/2. And so let's go ahead and take a look here. So we got, we go up spin, up spin, up spin. So notice how the first half of them are positive 1/2, and then down spin, down spin, down spin, and the second half are negative 1/2. And so if you take a look here, the first half of a block is going to be a positive 1/2. So again, the first half of a block will be a positive 1/2. Now, then what will happen is the second half will be a negative 1/2. So let's go ahead and do some, let's go and practice this. And so if you take a look, the first one is carbon. And so let's go ahead and find carbon on the periodic table. It happens to be right there. And so it happens to be this right here. So notice how N is going to be 2. The second quantum number is the block that it's in, which happens to be 1. Now, M is the position, which notice how it's -1, 0. And then the last one is the spin. It's in the first half of the block, so it is a positive 1/2. Now let's go ahead and do iron. So let's go and find iron. Iron's right here. So notice how it's 1, 2, 3, 4, 5, 6 into the D block. So 1, 2, 3, 4, 5, 6 into the D block. And so it is in the 4th energy level. However, it's the 3 Ds. So the N is going to be 3. A common mistake is that people put 4 because they see it's in the 4th row, but it's actually in the 3 Ds, so you need to put 3. So L is going to be 2 because that tells you which block it's in. M is going to be, well, we got -2, -1, 0, 1, 2, -2, so it's -2. And then notice how it's in the second half of the block, so it's going to be a -1/2. All right. Let's go ahead and do arsenic now. Arsenic is right there. All right, so it's 1, 2, 3 into the block. All right, so it's 4. It's in the 4th energy level because it's 4p. It's in the p block, so it's 1. It goes -1, 0, 1. So it's a positive 1. And then it's a positive 1/2 because it's in the first half of the block. All right, let's go ahead and do tungsten. Here's tungsten. So it's 1, 2, 3, 4 in. All right. And so you can see it's a 5. It's in the D block, which is 2. It goes -2, -1, 0, 1. And it's in the first half, so it's a positive 1/2. And then the last one is uranium, which is right here. Now notice how this is 5F, all right? So it's 5. It's in the F block. It's -3, -2, -1, 0. And it's a positive 1/2. And it's that simple. So go ahead and do the other practice problems, and then we're going to, in class, look at how we can figure out these quantum numbers in another way. But if you remember this chart, if you memorize this chart and the pattern that's within the chart, it's really not that bad. All right, well, you guys have a great day.